Assalamualaikum and good evening. We are from Group 4. We'll explain about the application of thermodynamics in an air conditioner. So first of all, we are going to introduce ourselves.
Okay, my name is Won Chonggang and my matrix number is 203232.
My name is Luqman Hakim bin Razdan and my matric number is 200354.
So my name is Muhammad Aiman bin Cik Muslim and my metric number is 203694.
My name is Sulaiman bin Ahmad and my matric number is 200307.
So I'm gonna explain about the air conditioner description. So air conditioner is a system that acts as a cooler that often used in the building like house and the vehicles like car. So the component in the air conditioner is evaporator coil, condenser coil, refrigerant, compressor, and expansion valve. We move on to the process of an air conditioner. So in an air conditioner, there are two coil, which is evaporator coil in the indoor and the condenser coil at the outdoor. It flows the refrigerant inside this process of an air conditioner. So first of all, evaporator will absorb the heat and then change the refrigerant into the vapor before it flows to the compressor. Compressor will dramatically increase the temperature and the pressure of the refrigerant before it goes to the condenser coil. Then the condenser coil will release the heat air with help of the fan at the condenser. Then the refrigerant will condense into the cold liquid and then go drive to the expansion valve. Then it change to the vapor cool before it go to evaporator coil again and release into the room. So this process is repeated and which we call as refrigeration cycle process. So this is the refrigeration cycle process of an air conditioner. As you can see, the refrigerant are flow from the evaporator coil to the compressor and then to the condenser coil, go through to the expansion valve before it drive to the evaporator coil again and release it into the room. So that's all for the description of an air conditioner.
Fundamental principle of the first law of the thermodynamics related to our application, which is air conditioner. So the first law of thermodynamics stated that energy cannot be created or destroyed. It can only change from one form to another form with the interaction of heat, work, and internal energy. Mathematically, energy of a system can be represented as delta U equal to Q plus W. So the internal energy of a system will decrease if the system gives off heats or does work, and vice versa. However, due to the first law of thermodynamics, the total change in internal energy of a system and its surrounding always equals zero. If the energy lost by the system, then it means that it is absorbed by the surrounding. And for example, if the energy of the system increase, it means that the additional energy is absorbed and come from the surrounding. Basically, the energy of the system and surrounding is conserved. From the first law of thermodynamics, we can conclude that the need of heat supplied to the air conditioner system from the surrounding is equal to the work done by the air conditioner system on its surrounding. So the total heat of the surrounding is equal to the work done by the system of the air conditioner.
Okay, now I want fundamental principle of second law of thermodynamics related to air condition. What is second law of thermodynamics? It's all about the quality of energy. So that energy is transfer or transform most of it is west. Classic statement state that it is impossible for a self-acting mechanic working in a cycling process without any external force to transfer heat from a body at lower temperature to a body at higher temperature. So it simply states that an air conditioner cannot operate unless its compressor is driven by a external power source such as electric motor. So I'm going to tell the detail of the process in air conditioner. So the process of air conditioner direct follow the causal statement of the second law of thermodynamics, where heat is taken in front of from a cold environment. What is applied and heat is expressed to a hot environment. And air conditioning effect is to remove heat from a cold environment, make the environment cooler, and transfer the removed heat to a hot environment, make the hot environment even hotter. So we may think that the air condition create cool air to lower the temperature in our room, but they actually extract heat from the indoor air and send it outdoors. So when the heat is removed from the indoor air, the air is cooled down. So it's the best way to think of the air conditioner process is heat flowing from the indoor to the outdoor.
So now I will continue with the analysis of the air conditioner. First one is the evaporator coil. This evaporator coil will absorb the heat from the room, and then we will turn the refrigerant in the evaporator coil from liquid state to a vapor state. So this evaporator coil, we can assume it as a heat exchanger. So why do I say so? Because its function is the same as the heat exchanger, where two moving fluid exchange heat without mixing. So for the second point is the thermostatic expansion valve. This thermostatic expansion valve is used to make sure the refrigerant that enter the compressor is in a vapor form only. This is because if the compressor cannot deal with a liquid refrigerant because it will damage the compressor. So how did the TXV do this? It will cause a large pressure drop in the fluid and by restricting the flow of the fluid itself. Hence, the fluid can be maintained at a vapor state. So for the third point is the compressor. This compressor will cause the temperature of the refrigerant to be far higher than the room temperature. So it will cause easier to eject the heat, especially with the help of the fan. This fan will make the works more efficient. So during this process, the gas also get condensed into liquid phase. For the fourth point, expansion valve, this will reduce the pressure of the fluid by the same method as the TXV, by restricting the flow of the fluid, but it will make the liquid refrigerant become much cooler than the room temperature. So this refrigerant liquid then will enter the evaporator coil again and will absorb the heat from the room again. So this cycle will keep repeating and repeating to make sure the temperature of the room is kept low enough. So that's all from me. Thank you.